Hello friends, welcome to another video in AI ML series. In this video, we are going to look into all the operations provided by NumPy library. It is a library in Python which is used for basic operations in AI ML projects. So let us start without any delay. So you can just install NumPy using pip, and you can just check the version of NumPy like this. I'll just run this cell, and you can see the version that I'm using for NumPy is 2.3.3. You can check your version in the same manner. I'll just move to all the basic operations that the NumPy library provides. So here, using the array function, you can just create an array from the elements. So as you can see the output of this block, I have run all the blocks beforehand, so you can just see the output of those blocks below them. So array has been created. Now you can also create multi-dimensional array using this format. You have to just provide nested arrays inside it, and it will create multi-dimensional arrays for you. And there are some methods provided by it to see the shape, size, dimension, and the data type of that particular array. So if you will look into this, I'm just printing the elements for array B. So here is, you can see the shape is 2 by 3, as the array has 2D array, and the number of rows are 2 and the number of columns are 3. But the size is 6. The size here means the total number of elements present in the array. So as the shape is 2 by 3, the number of elements that are present in the array is 6, which is 2 into 3, right? Hence the size is 6. Dimensions is the xy dimension, so it is a 2-dimensional array, right? Similarly, for a 3-dimensional array, the dimension will be 3. And data type is by default data type that the NumPy picks up. So here the default data type that NumPy picks up is integer 64, which takes 64 bits per element, hence the integer 64. Now there are few more functions provided by the NumPy to create initialize an array. So NumPy zeros, np.zeros, it creates array with these dimensions, with this shape, with elements as 0. So as you can see, I have created a matrix of 2 by 3 with all the elements as 0. Similarly, there is another method called once, which does the same, but is initialize the whole matrix by 1, as you can see here in this. Now you can just create arrays using these functions as well. So in numpy.arrange, in this it takes 3 parameters, and it takes the initial value, the last value, and the step. So here 0 is the initial value. So as you can see, array created by this starts from 0, then it goes up to 20, the value 20, and it takes the every second element from 0. So as you can see, 0 is included but 20 is not. So the last element is not inclusive in the operation, but it takes every second element, which is 0, 2, 4, 6, 8, 12, 14, 16, 18. So similarly, if I change it to 3 and run this cell again, you can see now every third element is getting picked up for this particular array. So if I go back, so here now the third element is getting picked up for this particular array. Now then again it is line space function, which takes similarly 3 elements. It will generate whatever number you will provide here, it will generate those many elements in the array with equally spaced values. So I have provided 0, 10, 10. As you can see, it starts from 0 and it ends at 10. So both the values here are inclusive, and it will create 10 elements which are evenly distributed within this range. So as you can see, if you will check, all the elements are evenly distributed. There will be minute difference, but most of the elements are evenly distributed, and it includes both the values present passed into it. So let's say if I change the value here to 5, I'll just generate 5 elements, then run this cell again. So you can see it generates 0, 2.5, 5, 7.5 and 10. They are evenly spaced from each other, right? So it works like this. Now we have this I method, which is like creating an identity matrix. So it takes a single parameter, which is the size of the matrix, and it generates a matrix, identity matrix by that size. So as you know, identity matrix is a matrix in which the diagonal, in which only ones are present in this left diagonal, all the other elements are 0. So you don't need to create identity matrix like this. You can just use this function. Okay. Now after this you can just perform minimal operations on a particular array itself. So here as you can see, A was my initial array with this 1 2 3 4 5 values. You can just add 10 to all the elements of the array. So if you will do something like this, array plus an integer value, then it will just add all the it will just add 10 to all the elements of the array, and the array will become finally like this. Similarly, you can do other operations as well, like multiplication, power, and square root of it, or anything. So basic operation, you can just provide the array name and the operation. It will just perform that operation on all the values of the array. You don't have to iterate over the array and perform operations over them. You can just do a simple trick like this. So I have performed these operations. As you can see, I have performed the power of 2, square root, and addition. So the results are here. Now we move to another operations, which is indexing, slicing, and reshaping. So I've just created a array of 10 elements using the arrange. So my initial array is looking like this: 0 1 2 3 4 2 9. Now I'm just finding out the element at index 5. So as you can see, as I have created the array from 0, the element at index 5 is 5 only, because in Python as well arrays are 0 based index, right? So index at 5 has the 5 element in it. Similarly, you can do something like this: provide a colon before the indexing. It will just say provide all the elements before this index. So as you can see, all the elements before 5th index, which is 0 1 2 3 4, are getting printed out. Then if you provide the double colon, then it will just give you every second element or every third element. So I have just provided 2 here, right? So every second element is coming. Let's say if I do 3 and run the cell again. Now let's look for the input. So every third element is coming, right? 0 3 6 9. So let me change it back. Now from index 2 to index 8, you want something like this, right? So you can just provide these 3 values like this. So first value provides the initial index, the second value tells the last index, and the third value tells you the step, what element you have to choose. So it will start from index 2, which is 2, then it will pick every third element up to 9th index. So 2 3 4 5 6 7 8, and that's all, right? So this is how this indexing works. Now you can just reshape the indexes, reshape the arrays as well. So I have created initially a single array like this only. As you can see, these two are the same statements, and I am reshaping them into a matrix of 3 by 3. So you can see the array looks like this. In case there is an error, for example, let's say let's try to do it for 3 by 4. So as you can see, it cannot be created. The problem is that this field, right? Because reshaping will not be possible in this case. Let's see the error. Array cannot reshape array of size 9 into a shape 3 by 4, because here the elements required for a matrix of 3 by 4 is 12, but arrange will provide you only 9 elements, right? Using these values. So the number of elements that are present in a single array and that should be present in our the matrix, they should match. Otherwise it will just throw a same error saying the elements do not match. So I'll just move back to 3 by 3, or maybe I can show you. Let's do it up to 13. Let's 13. Let's enter it. Now as you can see, my elements, my matrix is created, because number of elements given by the first array, which is 0 to 12, sorry 1 to 12, and then the reshape matrix, which is 3 by 4, which needs 12 elements, all matches to each other, right? So you can see the matrix is there. Let me revert this change and run this again. So now my matrix is created. Now you can just get the element at a particular position in a matrix, like we have done in any other language, providing the both index, where first value represents the row and the second value represents the column. So you will just get the value at row 1 and in column 2, which is 6. Now you can print a row or a column like this. So if you want to print a complete row, you can do something like this. It will just print you the whole row. So first row is getting printed. Now if you want to print the column, you can do something like this. Provide a column as the first value, and then the column number, column index. Then it will provide you that column only. Or you can print the submatrix. For example, from this matrix I just want to print a small part of the matrix, which is, let's say, from row 0 to 1 and from column 1 to 2. So here the second value is exclusive, it doesn't include that. So I'm just printing from 0 1 row, which is this row, and the last two columns, which is 1 and 2. So these two columns. So my array should be 2 3 5 6. So as you can see, this submatrix is getting printed. So you can just create submatrix using this method from a matrix. Now you can just do the same reshaping. I've shown you before. It's the same thing. You can just reshape the matrix according to the elements, or you can flatten them as well. So after you create a matrix, you want to convert into a single dimensional array again, right? So you can do it using the flatten. As you can see, the flattened matrix looks like an array, right? I have already I have a matrix of 3 by 4. I have just flattened it, and you can see the array looks like this. It will just put all the elements in a single array row wise. So as you can see, the first row is becomes the first 4 elements, second row becomes the next 4 elements, and so on. So it will just go on row wise, and it will just flatten the whole matrix. Now let's move to indices. Apart from the traditional way of printing the values in a matrix, you can just provide an array as well in case of indexes. So let's say you have created an array of 2 4 6 8. It's just simple. I'm just creating a value arrays with 4 values, and I'm just passing this indexes into the array that I have created here. So let's say I've this first array that I have created. So what it will do, it will just pick the elements from this array on those indexes for which the value is present here. So it will just pick the values from index 2, index 4, index 6, and index 8. So you can also create the array with all the indexes you want, and you can just pass it like a value inside these square braces, and it will just give you the elements present at those indexes that are present in this index array. Similarly, you can do for the matrix as well. If I show you the result, the elements are like this, right? These are the elements that are present here. These are the elements that are present in this array for those indexes. Similarly, you can do for matrix. You can just create arrays for rows and columns. The similar array that I have created here, 0 to 2 and 1 by 3. Then you can just pass them into the pass them like rows or columns. If you want to print rows, so you can see the rows are getting printed. Let me check. Scroll a bit. Yeah, you can see the rows are getting printed, and if you want to print a sum matrix, you can just pass both rows and as well as the columns. So the sum matrix will get printed. Okay, let's move to the even elements. Then you can just perform the same operations, similar operations on conditional wise. For example, if you want to print all the elements that are present in an array or a matrix that are even, so you can just pass the condition. So you can just pass a basic condition, true or false, which returns a true or false, and whatever elements for what element the condition will be true, that element will get printed. So I want to print even elements. I'll just pass this array remainder by 2 is equal to 0. So for each element, it will just perform this operation, and for whatever element the condition is true, that element will get printed. So as you can see, the even elements are only getting printed in the reshaped array. So our reshaped array is a matrix, right? It will just give you all the list of all the elements that are even. Similarly, in case of matrix, you can just pass the similar manner. In the similar manner, you can just pass the condition, whatever condition, even or odd, and it will just give you all the elements that are present in the matrix that fulfills that condition. Please notice that in both the cases, even if it is a matrix or a single dimensional array, the result will be a single dimensional array only. So this is the result of the array, and this is the result of the matrix, and both is a one dimensional array. Let's move to some other operations, which is view and copy in NumPy. So after creating a matrix, so the original array is like this only, right? This is our original array which we have created. Now we can just create a view of it. So I am creating a view of an array from this index 2 to 7. So if you will see my view array, obviously the second element is second parameter is exclusive here, excluded here. So the array that is being created is from index 2 to index 6, which is here. So this is just the view of the array, and if you change the element of a view, it will just reflect in the original array as well. So I am just changing the first element present in the view to 999. After that, if I'm printing my view as well as my original array, you can see the changes at both the places. So in the view it got replaced in the first position, right? Because in my view I'm just changing the first index, but in my original array this index belongs to this third index, right? Second index 0 1 2. So here, as you can see, it also got updated from 2 to 999, because view is something that is created from the reference. It is not a copy of the array, it's just a reference of that array. So any changes that will happen in the view, it will reflect in the original array as well. If you want to create a deep copy, you can just use the function copy. It will create a separate copy of your array, and any change in this will not be reflected in the original array. So I have created a copy as well, and then after that, on index 1 I'm just changing it to 555. So as you can see in my copy, the value has changed, but in my original array it is still 1 there at index 1, right? So the copy changes in copy does not reflect in the original array. So this is just the check to find out if the view shares memory with the original array or not. Just a check there. So here it's a function provided by the NumPy, which tells you whether the two arrays share the memory or not. So as we know, view is the reference of the original array, right? So all the changes made in the view are reflected in the original array as well, right? So if you will use this method to find out if these two arrays shares memory, then you can see the result is true. But same is not true for a copied array, right? Because copy creates a deep copy of the array. Now let's move to data type optimization in NumPy. So as you know, initially by default the data type picked by NumPy is integer 64. So integer 64 stores 64 bits for each element in the array, right? But for example, your numbers are small, you don't require this much amount of storage for each number, right? Then you can just tell your own data type while creating the NumPy array. So you can just provide a data type field here, in which you can just provide what type of data you want to store in that array, and it will just create data accordingly. So initially it is integer 64. I have just provided integer 32, float 64 or float 32 for these arrays I'm creating. So after creating arrays, I'm just checking how much storage the array is taking using the total number of bytes taken by the array. So if you will look down, integer 64 is taking more number of bytes than integer 32, right? And same is for float. Float 64 is taking more number of bytes than float 32, right? Because the number of this storage required for each element will be different in case of both. So this is memory uses. Now we can just convert the data type as well. So as you can see, I already have an array of float 64, right? I have created an array of float 64 here, right? I want to create a new array from it, but with different data type. So you can just use the method as type. Here you just provide the new method type, new data type for the elements of the array, and it will just convert into that. So if you will check, after converting it, new data type is float 32. I'm printing the new data type here, and the total number of bytes are also less, which matches the float 32 this size, right, that I have initially created. So it is converting float 64 to float 32. Mixed data type example. So in this array you have mixed data type, right? Like initially you are providing 3 values. So these 2 are integers and this is a floating value, right? So you can just provide a data type on that, and it will just convert all the values in that data type. So it will just convert 1 and 3 as well into a floating value. Now let's say you have a 1 million samples which 10 features each. For example, if you have lots of sample and each sample has 10 features. So let's say I'm creating random 1 million samples with a float 64 type, and I'm just converting into float 32 again. So let's say initially the type was float 64, I'm just converting it to float 32. We are just checking how much memory we are saving on that. So the float 64 it's taking 76 MB, but the float 32 is taking 38.515 MB, right? So we are saving half of the memory. So memory is just double, right? Because uh, it's taking 64 bits, but the element here is taking 32 bits, right? So we are just saving half of the memory, right? So if you have lots of data and you know what range data belongs to, you can just provide your own data type. You don't need to go by default because they take huge memory, right? If you want to save memory, you can just provide data type according to the data, and you can just save storage on that. Now we can just check the precision loss. So this is one thing that could happen while converting data types from one array to another. So let's say the elements present in an array, they represent the float 64, right? When you will convert them to float 32, number of decimals will be less, that will be present in the 32 bits will be less as compared to 64 bits, right? So there will be a small amount of data that will be truncated, or there will be some precision that will decrease, right? So I'm just calculating that here. What I'm doing here, after the conversion, I'm just subtracting the values of both the arrays. So if you will do something like this, right, in case of NumPy, it will just take all the elements from the first array, it will take all the elements from the second array, and consecutively it will subtract all the elements by each other. For example, it will subtract an element at index 0 by the element at index 0 here. Similarly, it will subtract an element that is present at index 1 and 64 by the element present at index 1 and 32, and so on. Now I'm just creating the absolute. I'm just taking the positive values out of it and creating a mean of it. After that, if you will see, the precision loss is very small because only the decimals are getting less, right? So the precision is there is a small bit of precision that will loss of precision that will happen, and you need to take care of that while doing the conversion. Now let's move to vector operations. So I'm creating again some random vectors of size 3. Let's see how they look like. So let me move down, and yeah, this is my vector 1 and this is my vector 2. So I'm using a rand integer function of size 3. It will just create values between 1 to 10, and it will just create a vector of size 3. So as you can see, randomly it has created vector 1 of 748 and vector 2 of 573. Now, as I have told you earlier, you can just perform operations on the whole array. So if I do something like this, v1 plus v2 or v1 minus v2, it will just take all the elements from both the array and it will just subtract or add them consecutively. So you can perform every operation, multiplication or division. I'll just show you. So as you can see, an addition, it is adding 7 and 5, 4 and 7, and 8 and 3. Similarly, while doing subtraction, it is subtracting 7 and 5, 4 and 7, 8 and 5, and so on. So you don't need to iterate over both the arrays and perform all these operations, right? You can just perform the operations using the vector names. So for creating the dot product is a product that is basically used in machine learning algorithms, right? If you have worked on them, dot product and cross product are the two main products that are used in those algorithms. So creating a doing a dot product, it just requires you pass both the vectors into this dot method, and it will just provide you the dot product of that particular vectors. So as you can see, if you will do a dot product of this, right, like 7 into 5 plus 4 into 7 plus 8 into 3, basically the sum of these three elements, right, 35, 20 and 28 and 24, it will come up to 27. So you don't need to multiply them and then sum them. You can just pass them into the dot product method of the NumPy. Similarly, for cross product, there is a method called cross, and it will just give you the cross product of those two vectors. So you can see cross product is this. Now this is just the verification. As we know, when we create a cross product of two vectors, it should be perpendicular to both the vectors, right? So I'm just verifying that. So there is a method called isClose. So this tells you how close a vector is to another vector. So I'm just creating the dot product of cross product and v1 and cross product and v1. So I have taken a cross product of v1 and v2, and I am taking the dot product of cross product plus and v1 and cross product and v2. So as we know, the cross product, if we take a dot product of two perpendicular vectors, it will be 0, right? So that is what I am checking here. So after checking the dot product of these two arrays with this cross product, I'm just checking if they are close to 0. So if you go here, this is coming as true. So for both vector v1 and v2, when you check if the cross product if we take the dot product of v1 and v2 with the cross products, then it is coming to 0. So this verifies that the cross product vector is perpendicular to both the vectors. Now if you want to find the magnitude of vectors, you can just use this method. It will just give you the magnitude of vector v1 and vector v2. So magnitude is nothing but the square root of when you square all these elements and take the square root of summation, then it gives you the magnitude of the vector, right? You can just do the same using this method, and it will just give you the magnitude of the vectors. After that, so this is just an example that we actually use in machine learning, right? So if you will check my neural networks 101, in which I have told you that initially we have some features, some inputs, right? So let's say these are our inputs and these are the weights that neurons take. So for each input you have a weight, right? So instead of going over the loop and multiplying them, you can just take the dot product of your inputs as well as weights and add a bias. So here I've taken a small bias, and you can just do something like this. If you have seen my previous video on neural network training, I have done the same there. And this is another method to do the dot product of two vectors. So here, instead of passing this these two vectors inside the dot method, you can just use this operator as at the rate, which does the same. It's just a new way to find a dot product. It does the same, just a new way to do the things. So as you can see, both of these will produce the exact same result. I'll just show you. So matrix dot products and matrix product, the both are same, right? So they will just give the same result, and if you will add the bias, the result will be this. Now after doing that, you can just pass the activation function as well, right? So these are our inputs, these are our outputs, and after that you can just provide the you can just pass them to the activation function. So as you have a vector in your result, right? So this is our vector. After doing the bias and everything, you have a result, right? Or you can pass the whole vector into a sigmoid function, and you can just use the NumPy operations to perform the operations for each element in the array. So here I'm using a sigmoid function, and for this array I want to apply the sigmoid function on value of each value of this array, right? You can just pass this in the sigmoid function as a param, and you can just use the numpy exp operation and pass your array here. Then it will just perform the sigmoid operation on each element of the array, and it will return you the result. So this is my input and this is my output, where each element is being passed to the sigmoid function, and this is the output of the sigmoid function for each element. Okay, now let's move to some other operations provided by the NumPy. So these are basic operations provided by the NumPy for statistics behavior, which is like sum, mean, median, mode, and all those things. So np.sum obviously gives you the sum of all the elements. Mean, median provides you the mean and median of those that vector. Standard deviation and variance is also there. It will just provide you the standard deviation and variance for that particular vector. And then you have argument minimum and argument max. So let's see the result of these all four. Let's move this to scrollable. So as you can see, if I check this, let's move up. Sum of these elements, the sum of elements from 10 to 50, right? So you can see the sum is 150, which is correct. Mean is 30, median is again 30. This is our standard deviation, this is our variance, and this is the minimal element present in the array and maximum element present in the array. So this is the output of this argument minimum and argument max. So it just tells you where the minimum element is present and the maximum element is present in the array. Then there are some trigonometric functions as well. So I'm just creating an array and I'm just converting them to radians. So this is, let's say these are the values in degrees, and I'm just converting them to radians. So this is our output. This is angular degree, which is our original array, and these are the outputs of radians. After that, we have round function, we have sine, cosine, and tan. It will just give you the sine, cosine, and tan values. These are all trigonometric functions, right? So for each trigonometric function, you can just use them like this. You don't have to calculate them using basic mathematical formula. You can just use the NumPy functions there. It also provides you sin h, cos h and tan h functions to get those values. Also, there are some basic operations present here, exponential, round and log as well. So all these functions, these are provided by the NumPy, and you can just for all of them you can just pass the vector as it is. You don't have to iterate for any of them, and for each element it will just perform that operation and give you a vector with the output. So here I'm doing the same again. I've created the sigmoid function, and I'm just doing the same again. I'm just passing the values in the sigmoid function, and here as you can see I'm using the NumPy exponential function and passing my vector here with a negative value, and it will just give me the it will just apply the sigmoid function on all the elements of this array, and it will just give me the result for that. So as you can see, I've just printed the output of everything: sine, cosine, sin h, cosine h, and exponential and natural logarithm, base 10 logarithm. So these are coming from here. This is the natural logarithm, which is the default logarithm value. This is the base 10 logarithm value, which is log 10, and this is log 1 plus x. So these are all the methods provided by the NumPy, and you can see this is the sigmoid example, right? This is the value. These are our inputs, and these are the outputs after applying the sigmoid function. Then we have other methods as well, like round, float, seal, truncate, and round. So these are all the basic operations you might already know. Seal is producing the next, moving up the value, like truncating the decimals and taking the next biggest integer, right? So let's say our original array is something like this, right? So rounded will be round, it will round up the values. Floor will be taking the base of the numbers, and seal will be taking the upper value of the numbers. For 1.23 the seal is 2, right? So it will be taking the seal of that. Truncates the decimal, and around this takes the value based on some precision. So here you have to provide how much floating values you want to take. According to that, it will just take the values, it will just form the values from the original array. Now similar operations you can do on a matrix. You don't need to perform them in an array as well. For matrix you can do the same. You can just pass the matrix and the round, sum and mean, standard deviation and everything, and it will just behave the same. So let's jump into the output. This is our original matrix. Here it has sum of elements, mean, standard deviation and the rounded mean for that matrix. So for all of them I'm not scrolling I'm not iterating over the matrix. I'm just passing the matrix inside the function with the correct parameters, and it just gives me the result. So here I'm just doing some small comparison between the NumPy arrays and the arrays provided by the Python, the basic arrays provided by the Python. So for that I'm just creating two different arrays, A and B, with similar number of elements and the random values, random 1 million values. So I'm just using the NumPy to loop over the array, and I'm just using the traditional method like for loop to loop over the array. So here in the first I'm starting a time, and initially I'm just looping over the whole array, which is my array 1, and I'm creating a third array by appending the elements of A and B. Now after performing the operation, I'm just ending my time and just logging the how much time it took. Same thing I'm using the I'm doing using NumPy operations, where I'm just adding the vectors A and B directly, and I'm creating the third vector using that instead of looping like this. It's the same operation, but the way is different. And for the same I'm just calculating the starting time and ending time, and I'm just printing the time taken by this operation. So let's see. So using the loop method it took something around this much time, and using the vectorized method it took around this much time, right? So results are identical. So after that I'm just checking if the results are identical as well. So this is my first operation, this is my second operation, and after that I'm just comparing both the vectors are close or not. So as you can see I'm just providing both the vectors, and I'm just checking if the elements of these vectors are same or not, which is true. So this is fine, and after that I'm just performing a calculation which says how much faster the NumPy operation is. As you can see, the NumPy operation is a lot more faster than the traditional method, traditional for loop, right? So that is why the people use NumPy methods to perform all their operations in machine learning, because this is like lot faster. This is just the graph. So loop is like 134 times slower than the NumPy operations. This is a huge time saving. So this is some example of broadcasting. Broadcasting is nothing but what we have seen till now. You can just perform basic operations on an array itself, right? You just don't need to loop over the array. So this thing is called broadcasting in Python. So it's the same. As you can see, I have provided two arrays and doing the summation of them, and then after that summation of them, and after that I'm performing other operations as well. For example, taking the square of the first vector and printing the result, or if you have an array which has values in let's say um, Celsius, and you want to convert them to the Fahrenheit, right? You don't need to loop over all the elements. You can just pass the formula for the whole array, like providing the whole array name into the formula, and it will just perform it for you for all the elements present in the array. So this thing in Python is called broadcasting. Now these are just the random functions that we have seen earlier, just the more thing. So you just provide a seed value, and you can just all these random functions to create a random array. So here I'm just using different random functions provided by the Python. Random takes a single input which tells you how much, which tells you the size of the vector. So you can see the normal distribution array. This is just the it is a single dimensional array created by this random elements. You can just provide other use other functions as well, which takes different inputs and create a random array. So here in the first example, I'm creating a matrix of 3 by 3 using the random values, and in this I'm just providing a random function which creates a integer random values. Here as you can see, the values are float, right? If you want random values in integer, you can just use this function. You can just provide the size and the number of elements and everything here, and it will just create the matrix for you. Then we have linear algebra operations. You can perform linear algebra operations on it as well. So I have created a matrix A, matrix B. Then I'm doing the summation, multiplication, dot product, and transpose, determinant, and inverse for that particular matrix. So all these operations are provided by the NumPy. So for doing a transpose of a matrix, finding the determinant of a matrix, or inverse of a matrix, you don't have to do anything. You can just use the functions provided by the NumPy as it is. Then handling missing data. So in if you are working on some machine learning algorithms, there are lot of scenarios where you don't have data in some particular fields or some particular cells, right? So you can just find it out using NumPy like this. So let's say this is my data, and this is my initial matrix, and I have some nan value here, right? So this data is missing at this place. Similarly, here the value is really large, which is like infinite. I'm creating array something like this, and you can just find out if the where the data is present. So useNaN just tells you, it will just give you the result where the data is not present. Similarly, isInfinite will tell you the result where the data is like infinite. So as you can see, only the last value is true, others are false. So you can just clean the data using like this np.isFinite data. It will just give you all the data which is finite. So it will just remove all the nan as well as infinite values from the data. This is your clean data now, and you can do whatever you want with this data now. Now this is just an example of data pre-processing. So as you know, if you have seen my previous video on neural networks, right? So if the data is shifted in one direction, you want to standardize it, right? Like centered it around 0. So this is just one example of that, where I am creating the two different vectors of heights and widths with different random values. So as you can see, these are my vectors of heights and widths, and as they are all as they all have positive values, right? So before providing them inside a machine learning algorithm, we standardize them, right? So this is just the formula for that I'm using. So I'm just taking the mean of the heights and widths, and then subtracting the mean by their respective heights and widths, and dividing by the standard deviation of those. So after doing this, you can just see my data is centered around 0, right? Like some values are negative, some are positive, and it's like really centered around 0. So this is how you can just do the data processing using NumPy, and use it in your machine learning algorithms. So these are the other methods provided by the NumPy, like to find the correlation and everything. So these are my heights and these are my weights, right? If I want to find the correlation between my heights and weights, I can just use this method, provide my height standard deviation and standard deviated weights into it, and it will just give me the correlation between them. Now let's below. This is just another example I'm taking where I'm calculating the uh, intercept and slope. For example, let's say you have a linear equation ax plus b, right? So here x is your input and a is your slope, and b is the intercept, right? So if you have values for that, for example, I'm just creating two random vectors. So I'm just creating a x random vector. This is my random vector x with some random values, and I'm just creating a vector y using some using a normal equation ax plus b, where my a belongs is to 2.5 and b is like 5, and I'm just adding a small noise to it. So I'm just to make it more like real life data, where you don't get exact data, right? To make it more real, I'm just adding a little bit of noise to each output. So this is my y after this calculation. Now you have let's say y and x. Now you want to find out in real life scenario, let's say you have x and y, you want to find out what your slopes and intercept are, which is like 2.5 and 5, and we will just use our calculation to find these. Let's see how it results. So I'm using this, I'm using inverse and everything. I'm just calculating the slope and intercept for x and y as inputs, and you can see after all this calculation, my slope and intercept are coming like this, which is 5.35 and 2.50, which is like really close to my actual values, right? Which is 5 and 2.5. So these are really close to my actual values, right? The difference is because of the noise that I'm adding here. So the noise I'm adding here, right? This is the difference. So let's remove it and run it again. So now you can see they are like pretty close, right? The intercept is 5 and slope is 2.499, which is like really close to 2.5, right? So because of the noise, the difference was there. But this is how you can use your NumPy library to find out to perform different operations that are used in ML operations. Okay, I hope that's all for this video. I hope you liked it, and thank you.